We begin by looking at what the graph of the derivative of this function would be. If we have this function, again, what is its derivative graph going to look like? This is f of x. We want to graph f prime of x. Well, we can notice that the derivative goes through several phases. For example, it appears to be about 0 here. And of course it's 0 here because of course the slope of the function is 0 at both of these points. Now to the right of this 0, the function has a positive slope, so we're going to say that the derivative is positive. If y stands for the function, I said f a minute ago, but let's say it's y because that's what I have written down here, then we're going to say that y prime is 0 here, y prime is greater than 0 in this region to the right of this point. Y prime is 0 here. We can see that every place except here it looks like y prime is negative, so that it appears that y prime starts out negative with a large negative value here, and then y prime approaches 0 and actually maybe hits 0 here, and then it becomes negative again. Gradually, then more and more quickly it goes into negative numbers, and then it levels off and comes back up to 0. And then it goes through positive numbers, going through larger and larger positive numbers because the graph appears to get steeper and steeper, so that the slope gets greater and greater. If we're going to graph that behavior, the graph is going to look something like this. We start with a large negative y prime. There's a large negative directly below this point. We reach 0. Well, here's 0. We come up and gradually approach 0 as the slope of this function gradually approaches 0. Then we go into negative numbers gradually, then more and more rapidly. So we go into negative numbers gradually, then more rapidly. Then we level off and start, we reach a maximum negative value about here, the maximum negative slope corresponding to the low point of the f prime graph or the y prime graph. And then we approach 0 again, so we come back up to 0, and then we go into positive values of the derivative. So this would be a graph of the derivative of this function. If we look at another function, a function that maybe looks like the peak of a parabola or the top of a sine curve or something, we see that the derivative f prime is 0 here, that f prime is greater than 0 on this side, and f prime is less than 0 on this side, f prime again being the slope. Positive slope, negative slope, 0 slope. Positive slope going towards 0, then moving into negative numbers away from 0. So we see that we're going to start at some It looks like I've really messed up this graph here. It looks like I'm starting with a negative value of my derivative and going to a positive value. I must have done that in class. So we're going to obliterate that graph right here before your eyes and say that we're going from a negative. You know, some days it doesn't pay to get up out of bed. Okay. I was distracted by some kind of a brain event there, and you'll have to forgive that. That shouldn't have been crossed out. We'll leave it crossed out just to show that I can make mistakes on my feet as well as anybody. But we have negative value of x and a positive value of f prime corresponding to the positive value here. And we're going to go over to a negative value of f prime on this side. Now there's a question of how we go from the positive to the negative. If this is a quadratic function, we know that the derivative is a linear function and will go by a straight line. So if this is part of a parabola, the straight line is appropriate. If it's a sine function or some other function, it doesn't necessarily have to go in a straight line. It might go over here and then down like so. It might go down like this and over like so. It could go like this, like this. There excuse me, many ways that this could go from a positive value of the derivative to a negative.